Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on this review for 10.1 and 10.6. All right, so, we did a review for 10.1 and 10.3 already, so a lot of these problems are going to show up the same way. So if you want like a better review or like a more thorough review of those sections, you can watch that review video. I'm just going to use the methods that I used in that video to solve all these kind of quickly. So convert each degree measurement into radians and radians into degrees. So the way that I wrote that up last time was just as a ratio and another ratio equal to each other. So in other words, a proportion. And here's how it would work. If you have the radian value and you divide it by 2 pi, that'll be equal to the degree value divided by 360. Okay, and then you can just solve from there. It's pretty easy. So like if I have the degree value 105, I just, put that in over here, 105, and then just, simplify it. So you can use your calculator if you want to simplify the fractions. Let's see what we got here. Okay, so 105 divided by 360 gives me that. And then if I convert that back into a fraction, you get 7/24. So that turns into 7/24, which is equal to the radian value, which I'm solving for. I'm going to call that x over 2 pi. And then if I just solve for x, if I multiply both sides by 2 pi, here's what I get. So multiply that over. X equals 7/24 times 2 pi. So if I multiply the 2 pi times the 7 in the top, then I would get 14 pi over 24. And then I just reduce the fractions. So 14 and 24 are both divisible by 2. So this turns into 7 pi over 12. And that would be my answer for this one. That's the number of radians that this is equal to. So it's just a conversion into radians. Okay, and then do the same thing with number 2. So same proportion. And I have a degree value. I've got negative 330, so I'd put that up here, negative 330. And then I'd use my calculator and reduce it. So negative 330 divided by 360 gives me that. And then I convert that into a fraction. So I get negative 11/12 equals the radian value that I'm solving for over 2 pi. So the next thing that I do is I multiply 2 pi over. So I get x is equal to negative 11/12 times 2 pi. And then 2 times 11 is 22. So this turns into negative 22 pi over 12. And then 22 and 12 are both divisible by 2. So I'd reduce it a little bit more. Negative 11 pi over 6. And that would be the answer that I'd end up with, negative 11 pi over 6. And you might remember that 330 is like one of those unit circle angle measurements, and the unit circle radian value that's established with 330 is 11 pi over 6. So if I have a negative 330, it's equivalent to negative 11 pi over 6. So if you saw that, you can use that shortcut if you want to as well. Okay, so then I've got now a radian value, 35 pi over 18. So I put that over here in terms of the radian, 35 pi over 18. Well, really quickly, the pi's cancel out on there. So I get 35 over 18 over 2 equals the degree value that I'm looking for, x over 360. And then you can, cross multiply it if you want. So I get, you can just multiply the 3x over. So, the 360 over. So I multiply the 360 over. So 360 times 35 over 18 and then over 2. And then I just let my calculator do the rest of it. So let's type it in. 360 times 35 over 18. And then divide that by 2. So 350 degrees. That's the answer that I'd end up with for x. So 35 pi over 18 is the same thing as 350 degrees. Okay, and then I do the same thing with The next one, negative 7 pi over 9. All right, so right away the pi's will cancel out. So I get negative 7 over 9 divided by 2 equals x over 360. Then I'd multiply the 360 over. And then I'd let my calculator do the rest. So let's see here, 360 times negative 7 over 9. And then divide that by 2. I get negative 140 degrees. So that's what this one's equal to, negative 140 degrees. And don't forget your units. Sometimes we're really strict about units, so just make sure that you got it. Find the measurement of each angle. Okay. Well, first off, it's going in the wrong direction. Usually, it's supposed to go like this way, right? But it starts at 0 right here, and then it goes down. So it's going to be a negative degree measurement, and it goes in a full circle. So that's 360 degrees. And then it goes. It keeps going 90, another 90, so 180, and then another 90, 270. So 270. And then it goes an additional 70 degrees out to here. So if we just like add all those together, that'll give us the angle measurement. But then we got to remember that it's going in the negative direction. So we're going to have a negative on it. Okay, so let's figure out what it's going to be. So 360, let's use our calculator. What the heck? 360 plus 270 and then plus 70. That'll be 700 degrees. So it's going to be a negative 700 degree angle. Okay, there we go. And that might make sense because it's not quite two full rotations. If it was two full rotations, that would be 720 degrees. But, this measurement would be 90 degrees. So if I have 70 there, there's 20 left over there. So it's like 20 degrees shy of two full rotations. So that could also make sense for it. Okay, and then this is going in the positive direction. So we go 90, 180, 270, 360 degrees. So one full circle. And then another 90 and another 90. So that's up to 180. And then another this much. Well, I don't know how much that is. Oh, shoot, look at that. It's got pi sixth. Do you know what pi sixth is, just off the top of your head, in terms of degrees? I do. It's like 30 degrees. If you didn't know that, that's okay. You can figure it out this way. Like, you can do the whole proportion thing and all that stuff. Pi over 6 divided by 2 pi, and 360 and x. So, the pi's cancel out, so I just have a 1/6 in the top and a 2. And if I multiply both sides by 360 on my calculator, if I wanted to, I could just say it's 360 times 1/6 and then divide it by 2. See, it's 30 degrees. So that's 30 degrees. So I'm 30 degrees shy of getting to that 90. So that means that there's 60 degrees left over here. So, on my way through this, I went through one full circle. So that's 360, another 90, another 180, and then an additional 60. So I add on 60 on top of that. And that'll give you my angle measurement in degrees. So 360 and 180 is 540. 540 plus 60 is 600. You can do that on your calculator if you want. But it has like this green angle in terms of radians. So then what I would want to do is just convert it to radians. So I can just use my little trick again with radians. So it'd be 600 over 360. So I'd convert that fraction, reduce it down. So let's see, 600 divided by 360, and then convert it to a fraction. So 5/3. So whatever my radian equivalent to this, I'd set it equal to 5/3. So if I multiply both sides by 2 pi, I get my answer. I got to simplify it a little bit, but it's pretty easy because 2 times 5 is 10. So this would be 10 pi and then over 3. So this would be my answer right over here in terms of radians. Let's see. So find a positive and a negative coterminal angle. Coterminal angles are angles that we find by just adding 360 or 2 pi until we get either positive or negative, whatever we need. So like a positive coterminal angle to 208 degrees would be 208 plus 360, because that would just add on a complete circle. It would be like at the same location. So let's add those up. 208 and 360, that'd be 568. So there we go. Since this angle measurement is positive, this is a positive coterminal angle. And then to find the negative coterminal angle, I'd start with the one that I have, 208. I'd keep subtracting 360 until it's a negative angle. And it's not going to take much. It'll just be this first one. See, watch, 208 minus 360. There you go, negative 152. So negative 152 degrees. There's my negative coterminal angle. Oops, my bad. 208 plus 360 is 568. I bet you guys all saw that, didn't you? Yeah, sorry about that. Made a little mistake there. Okay, and then we're going to do a positive and a negative coterminal angle for the next one as well. So we start off with negative 265, and we're going to add on 360. And we're going to keep adding 360 until we get a positive coterminal angle. But, it'll actually do it in the first try, because watch this. If I take negative 265 and I add on 360, I get a positive angle. So my positive coterminal angle with negative 265 is 95 degrees. Okay, let's get a negative coterminal angle. So we start off with our original angle, and we just keep subtracting 360 until it's another negative angle. Well, you're going to get that done in the first try. So if you do negative 265 minus another 360, it's another negative angle. So there's our negative coterminal angle, negative 625 degrees. All right. Now let's do the same thing with radians. So we're just going to take that radian value that we have, 13 pi over 10, and we're just going to keep adding 2 pi onto it until we get a positive radian value. And, we can do that in the first try. I showed you a shortcut how to do this in the quiz review, and I'm going to utilize that shortcut. I just add the 13 tenths and the 2 together, and then I put a pi on it at the end. So watch, I do 13 over 10, then plus 2. I'd forget about the pi's for a second, and then I'd convert that into a fraction. So 33 over 10, and then I just put a pi on it. So 33 pi over 10. And it's positive, so that's a positive coterminal angle in terms of radians. Now I'm going to take 13 pi over 10, and I'm going to subtract away 2 pi, and I'll hope that this gives me a negative coterminal angle. So I'd start off with the fractions just like I did before, 13 over 10 minus 2. And yeah, it looks like I get a negative number. Cool. So then I just turn that into a fraction, negative 7 tenths. So negative 7 pi over 10 will be my negative coterminal angle. Okay, and then number 10, same thing. I take negative pi thirds and add on 2 pi. And this is going to be until I get a positive number. So that's negative 1/3 for the fraction, then plus 2. And yeah, sure enough, I get a positive number, so I'd convert that into a fraction, 5/3. So I get 5 pi over 3. All right, there's my positive coterminal angle for radians. And then I'd take negative pi thirds and I'd subtract away 2 pi. And this will give me my negative coterminal angle, probably. So let's check my fraction, negative 1/3. And then minus 2. Yeah, that's a negative number, so I convert that into a fraction. I get negative 7 over 3. So negative 7 pi over 3. So there's my negative coterminal angle, my positive coterminal angle. And then let's see, so reference angle. So reference angle is the shortest angle that you get to the x-axis. So it looks like it goes all the way over here. Well, if I go from here to here and I just stop right there at the x-axis, that's 180 degrees. So how much is left over for this little guy here? Because we go 190 all the way to the blue line. So if we take away 180 of it, that means that there's 10 degrees left over here. And that is my reference angle. The shortest angle from that blue line that we have there to the x-axis is 10 degrees. So 10 degrees is my reference angle. It's the same thing here. You can just find out how much is left over here. Okay. And it looks like the way that we can find that is actually pretty easy. If this is negative, right? then this is one complete circle. So guess what? Our coterminal angle is going to give us exactly this. So if we just add on a full circle, so negative 20 pi over 9, and we add on a full circle, 2 pi, it'll give us the remainder, so like this much, which is exactly the reference angle that we're looking for. So let's use our calculators and find those fractions. So negative 20 over 9, and then plus 2, and convert it into a fraction. So this little part right here is the remainder, negative 2 over 9 times pi. And that's our coterminal angle. It's the shortest angle going to the x-axis. Okay, and then the last ones, these would just be unit circle things. So if you have a unit circle on your test, you just reference it. I'm sure that we have like a unit circle somewhere around here, but if you have one, cool, just use that. All right, so I'll just draw a really crude one real quick, and just keep using it. So this says I need the cosine of negative 90. So negative 90 starts at 0, and then it goes down 90 degrees. So that means that I'm going to be like right over here. And at that point on your unit circle, the cosine would be 0, because that coordinate is 0, negative 1. So cosine is the first one, sine is the second one. So the cosine at negative 90 degrees is going to be 0. All right, now the sine of 225. Okay, so let's see, 225, if you use your unit circle, positive 225 is over here. And the sine that's like right in the middle, for that, sine is going to be that coordinate is going to be negative square root of 2 over 2, negative square root of 2 over 2. And, it goes cosine then sine. So sine is going to be negative square root of 2 over 2 for this one. For the cosine of 225 degrees, well, it's the same exact spot, so it'll be negative square root of 2 over 2 again, because now it's the cosine, which is like the first one on there. Okay, sine of negative 180 degrees. So on my unit circle, negative means that I go like this way, so I start at 0. And if I go negative 180 degrees, it's going to put me in the exact same spot as 180 degrees. And at that location, the coordinate's located at negative 1, 0. So the cosine is negative 1. The sine for that is 0. All right, and then let's see here. Now we've got sine of negative 2/3 of a pi. So I can just use my unit circle for that as well. If you're a lot more comfortable with degrees, I was much more comfortable with degrees when I first started doing this stuff. So I would usually just take the radian stuff and convert it into degrees. So if I had 2 pi over 3 over 2 pi equals the degree value over 360, well, the pi's would cancel out first. And then if I multiply 360 over, I'd get 360 times 2/3 and then divided by 2. So if I use my calculator, let's see what that angle measurement is. So 360 times 2 over 3 and then divided by 2. And I get 120. So this is 120 degrees. So negative 120. So if I went negative 120 degrees, so if I started like right here, then went negative 120 degrees, that would put me right over here, which is located at, what would that be, 240 degrees? And at that location, the sine, or the cosine is negative 1/2. And the cosine is negative square root of 3 over 2. So what's it asking for? It's asking for sine. So sine would be equal to negative square root of 3 over 2. And, some of these are just like already on. You might even know what they are, like pi fourths. That's just 45 degrees. So if I go like negative 45 degrees on my unit circle, that's like down this way, 45 degrees. So it'd be like right here. And the coordinate at that point is going to be square root of 2 over 2, comma, negative square root of 2 over 2. So that means that if I'm looking for cosine, it's like the first value there, which would be square root of 2 over 2. Okay, 2 more. Square root of pi over 3 is the same thing as saying 60 degrees. So pi thirds would be like up here. And at that coordinate, it's 1/2, comma, square root of 3 over 2. And if I'm looking for the cosine, that's the first one, so it should just be a half. All right, last one, 3 pi over 2. So 3 pi over 2 on your unit circle is over here. It's like starting here and then going all the way over here. So there's 270 degrees. And at that coordinate, it's going to be 0, -1. Isn't that where we just started? Yeah, we started that with number 13. So the sine is going to be the second value, so cosine and then sine. So sine is -1 for that one. Okay, I think that's long enough for this video. That's like pretty much all of the 10.1 to 10.3 stuff. So just a recap of that. And then the next video, I'll do the 10.4 to 10.6 stuff. Okay, I hope this was helpful for you. If you need more examples of this stuff, check out the quiz review for 10.1 to 10.3. I also go through like more steps with those problems, and I go through a little bit slower. So check it out if you need it. All right, other than that, I'm off to the next video. I'll see you then. Bye-bye.